Hello, Kitty. Are there any other quizzes? Okay, last class period, we started, so again, in this topic 6 schema design folder. There's a lot of things. We're going to be spending 2 weeks on it. And last class, we started talking about this, this row overhead information here. And I think we're going to finish that today, but I also want to make sure that I do an example problem from the pagila-hw3, which is now posted. And so just to make sure that we get that example problem completed, I want to start with that example problem, and then we'll come back to the row overhead, come back to this set of notes afterward. So we should, I think, finish this today, but I really want to make sure that we get this example problem done, so that's what we're going to start with. The homework, again, I've extended it to next Thursday, so you have a full week to work on it instead of Tuesday like normal, is this pagila-hw3 folder. There's a relatively long, if you click on that, a relatively long explanation about how to get the pagila data for this folder, but that's not going to affect the problem number 5 is what I want us to work on, problem number 5. And so you don't need to do that right now. If you want to follow along with what I'm doing, you can just quickly clone the repository or work inside of your pagila-hw3 repository that you already have the data with, and you'll be able to follow along and with me exactly what I'm doing. And then later on, you can follow these steps up here, which are important for some of the other problems. So let me get my get into a pagila-hw3 folder in both of these locations, /pagila-hw3. And again, you can work inside of pagila 1 or 2, doesn't matter. If you want to follow along, you can also quickly clone hw3 onto the Lambda server to follow along there. This problem 5 is going to not need any of this new updated data, and so what we're going to do, you can follow along anywhere. And the particular problem that I want us to look at, so if I do an ls of the SQL folder here really quick, you can see that, so there's about the same number of problems as in the previous ones, but this problem number 5 has many different variations on it. So starting from just 5 by itself all the way up to version F. So there's 6 different versions of it. And I want us to do just this very first one in class just to make sure that you have a good stepping point, a good starting point for completing all of these variations of this problem. And so up here, I'm going to open that 5.sql, and we'll take a look at the statement of this problem. Before I get started on talking about what the problem is and solving it, are there any questions about where I'm at or what we're doing right now? Yes?
Can we clone it from the GitHub? Should we do it as a branch?
Good question. The question is, when cloning this pagila-hw3, should you get do you want to be on the master over here, or do you want to be on the commit that's pointed to by the hash right here? It turns out they're exactly the same thing right now. Part of this big long set of instructions is explaining a little bit about the difference between those things. But it'll be in the context of this pagila submodule in particular. But yeah, you can just clone the pagila-3 homework assignment, and then you'll be in a good spot. You'll also have to do the submodule init and update to get the data as well. Good question. Any other questions about where we're at, what we're doing right now? Yes.
You're doing the standard number 5.
This is the 05.SQL, not one with one of the letters on it. Okay, so what this problem is asking, so you love the acting in the movie American Circus and want to watch other movies with the same actors and write a SQL query that lists the titles of all movies that share at least one actor with American Circus. And my hint down here is that this can be solved with a self-join on the film actor table. And we haven't seen any self-joins in the Pagila homeworks yet. We talked a little bit about them in the notes for the quizzes. We just, in your quiz today, you had a self-join. But again, one of the differences between the quizzes and the Pagila is that the quizzes focus more on the mechanics of what do the things do, and the Pagila is more on the why do you do it, more the intuition, more the semantics of what a self-join in this case means. And so I want us to talk a little bit about the semantics of why you might want to do a self-join, how you can, what are the triggers in your brain that should make you think self-join. Maybe the most obvious one is that this first problem 5 is a self-join, so probably all the other ones with a letter that are problem 5 are going to be self-joins. But some of the later ones as well are going to be self-joins, and there's not going to be like a hint that tells you this should be a self-join or should not be a self-join. So the first thing I'm going to do is coming back over to the Pagila homework. I want to take a look at this this schema, this picture that we've been looking at. It's called an ER diagram, and talk about what are the sort of clues that certain tables might have self-joins with them, and certain tables probably won't. And in this case, there are 2 tables that jump out to me as being very likely to have self-joins. It's this film category table right here and this film actor table right here. You can see that in both of these 2 tables, there's 2 stars inside of this table. Again, these stars are representing a primary key in the table, which isn't something that we've fully talked about, but I've said before that these stars are things that you're likely to want to join on. And anytime a table has multiple of these stars, that's one clue that a self-join is something that's going to happen frequently. So the film actor and the film category tables likely to be self-joined on. And in this homework assignment, those are the only tables that you will have to do self-joins on. My solutions only use self-joins on film category and film actor. One of the semantics about what this film actor table is doing is it's somehow connecting this actor table over here to the film table over here. It's telling us which actors belong to which films and which films belong to which actors. And the film actor relationship is different than a lot of relationships in that it's what we call a many-to-many relationship. That one film can have many actors and one actor can have many films. Anytime you have that type of many-to relationship, there's a very common pattern where you have your 2 objects, in this case film and actor, and some sort of connector table connecting them that only has a primary key inside of it and nothing else. In this case, it has this sort of last update thing. That's just like an administrative thing. It's not somehow real data that we really care about. It's not like the name of the actors or the title of the film, something like that, that's more real data. It's just some sort of metadata. So this pattern, again, of you have this many relationship. One film can have many actors. One actor can have many films. Often results in this self-join. Similarly, for category in film, these categories, again, are things like action movies, science fiction, comedy, children's, and so on. And one category, there are going to be many films in one category, but one film could also be in many categories, like very common for a science fiction movie to also be an action movie. So that's why we have this sort of film category connecting table. Okay, so that's intuition a little bit on spotting these self-joins. If you're thinking about films and actors or films and categories, likely to need to do self-joins. And so now let's walk through the procedure of actually solving this problem with a self-join. So again, it's saying you love the movie American Circus and want to watch other movies with the same actors. I'm going to start here by writing a SQL query that just finds the actors of American Circus. So that might look something like, and I'll just start with a select star. I'm not worrying about the columns yet, just the joinings, the tables. Select star from film where title equals American Circus. So that gets me my actual film. And then if I want to get the actors themselves, I'll need to do something like joining on this film underscore actor table, film underscore actor on the film ID in this case. That's the only thing they have in common. And then joining on the actor table using something like the actor ID, again, the only thing that they have in common. And this right here will get me all of the actors inside of this particular this film right here. Maybe we'll run this here in a second, but I'll make the columns a little bit nicer up here in order to run it. I'll do the title, and then maybe I'll just do the yeah, I guess we'll do the actor ID and the first name and the last name up here. Set no number, so I can copy and paste this down here. Control R, enter my P-SQL environment, and then copy and paste that down here, hit enter. And here we get that there are 5 actors who are in the American Circus movie. Any questions about anything that I've done so far? Okay. Again, maybe like just high-level intuition things are the most important things to be grasping, focusing on at this point. And the first like high-level intuition thing that you should be noticing is that I didn't just like immediately try to write a SQL query that solved this entire thing in one go. I'm somehow breaking it up into parts that seem like they might be useful for me. And so the query here again is write a query that lists the title of all movies that share at least one actor with American Circus. And so the first thing that seems like I might need for that is like who are the actual actors? And so that's what I'm starting with here. Who are the actual actors? Okay. Now that I have this list of actors down here, the next thing that I need is what are all of the movies that each of these actors are in. So I started going from film over here to actor, and now just sort of following my nose about what this problem is saying, the next step is that for each of these actors, I need to get all of the movies that they're in. And that's what's going to make this a self-join, that I started going from the film to the actor, and now I have to go back from the actor to the film. In order to make this work, maybe I'll start with one thing that's not going to work. The first thing you might think about in order to go, so I went from film to film actor to actor. Now we need to go back from actor to film. You might try to do something like join film actor using film ID, and then join again on film using film ID. So this film actor, sorry, I'm thinking going actor ID, joining from this actor column. We're going from this actor column back to the film column here, this actor column, joining on film actor, and joining back to film right here. So we're starting from film, going to actor, and then going back to film. And let's run this and see what happens. So I'm going to copy all of that and paste it down here and hit enter. And you see that we get this error message down here saying this table name film actor specified more than once. Okay, so that's we've seen that before. That happens with self-joins. I need to somehow name all of these tables that happen more than once. The sort of common thing that I do is like just take the first letter of the name, and then for the first time I use it, put a 1, and then the second time that I use it, put a 2. So FA2. And then over here, F2 like that. And let's copy and paste that now down here. Okay, now we're still getting some more errors, different errors, so we're making progress. Error column name film ID appears more than once in the left table. So over here on this using, it doesn't know like which film ID should it be joining on, and that's the key thing that we should be observing right now. It doesn't know which film ID to be adjoining on, because there's two film IDs. There's one from this table and one from this table. So in both of these locations up here, it's not going to know which one it needs to be joining on. So the first, I guess, big picture thing to think about is that when you're using a self join, you won't be able to use this using clause. You're going to we'll have to use the on clause so that you can actually specify which film IDs here that you're talking about. And so now let's change this to an on of f1.filmID. So this film up here connecting to this actor ID down here, f1.filmID equals fa1.filmID like this. Then down here, this using clause, I'll change this to an on of this fa1.actor ID equals actor.actor ID like so. Down here, this join next, film actor 2 on. We're joining on the actor ID, so actor.actor ID equals fa2.actor ID like so. Last one down here with this using on. And now joining F2 to FA2, we were joining on the film ID right here. So CI parenthesis, delete everything inside the parentheses, put me in insert mode. Escape U for undo. What I did was CI parenthesis, a common thing I do, common to want to delete everything inside of a parenthesis and type something different. CI parenthesis is the shortcut in Vim for doing that. And so it's film ID that I want to work with on here. So f2.filmID equals fa2.filmID like so. Do that. Run this whole query now. We still have the title being ambiguous up here. It doesn't know up here and down here which title we want to select from. Here, when we were first writing this query, we started with these three tables right here. Everything was working, so I'm thinking this title right here should be the F1 dot title like this, and down here the F1 title like that down there. Let's try that, see what happens. Run all of that and hit enter. Oh no, still getting so many errors down here about the actor IDs being ambiguous now. I'll do it on actor.actor ID, and I'll just qualify all of these different columns up here. So annoying thing about self-joins, again, you're going to have to do a lot of qualifying all of your column names, wherever they're appearing, inside of the join condition, outside of the join condition. And I think I've done it all now, but let's run this and do another one last check. Okay, finally, we're getting results here that it's actually running. The results seem kind of weird that we're getting a lot of American Circus and Kevin, a lot of duplicate rows down here. But at least it's not giving us any syntax errors anymore. Any questions on just what I've done so far, why I had to do all of this table qualification? Avizer.
Why did you take the table twice?
Question is, why did I get this film table twice? So what I started with was a query that was just like from here to here. So getting all of the actors in a particular film. But what the problem is asking for is not just all the actors in a film, it wants all of the films that those actors were in. And so I had a list of actors, starting with the films, I had a list of actors, and I needed to get all of the films for those actors. And so my idea was to go back, starting from the actor table, now out to the film table. And that's the key thing that's causing this to be a self-join. It's a self-join because the film actor and the film table's appearing multiple times. Good question. Yes.
Why are we selecting F1 title when we're like saying that F1 title is equal to American Circus? And we want to do that.
Yeah, so this is a fantastic question, and I'm going to rephrase the question for everybody by rerunning this query down here and observing what happens. When we reran this, we first observed that there are a lot of duplicate rows in this results. And so this should strike us as probably we're not quite going down on the right track at this point. That we probably don't want to have all these duplicate rows, that we were trying to get all of the different films that say, in this case, Kevin Bloom was in. That we saw that Kevin Bloom from our previous query was one of the actors in American Circus, and now we need a list of all of the films that Kevin Bloom has been in. Similarly, coming down here for Rip Crawford, we need all of the films that he has been in, but we're only getting American Circus repeated a bunch of times. And the particular question was like, why do we have f1.title up here if we have this clause down here saying f1.title down here? And this explains the behavior that we're observing down here. That if we're outputting f1.title up here and we have a clause down here that we're only considering those rows that satisfy f1 title equals American Circus, then we're only ever going to be outputting American Circus down here. And so that's why all of these columns are American Circus. And so the first most obvious thing to do to fix this is that we should not be having the F1 title up here. We should be having some different, something different up here. And in this case, the only thing different is this F2 title to use. So if I press Shift F1 to take me back to the left, again, Shift F, Shift for to the left, F for find, Shift F1, find the 1 to the left of where my cursor was. Replacing that with 2 seems like a potentially reasonable fix to what we were just talking about, observing that all of these titles are the same. And again, when this was F1.title up here, the reason all of these things are the same is because down here, we're enforcing that F1.title is always equal to American Circus, so that where clause is enforcing that this column up here always going to be American Circus. Changing that to F2, I don't know if that's going to fix the problem exactly for us, but that's at least going to not have the problem of American Circus repeated everywhere. Another thing to observe is that we talked about on our joining sort of journey, starting from film 1 up here, going down to actor, and then from actor wanting to go down to film F2 down here. This film, the intuition was that it was going to have all of the films that the actors were inside of. But I'm not using this F2 table anywhere. Anytime you have a table in your list of joins, probably you should be using that table somewhere. If you're not using it somewhere, then why are you joining it? And I'm not using that F2 anywhere up here in the columns. I'm not using it anywhere down here in the where clause. So that's another indication, another reason why I would think this should maybe be F2 instead of F1. If we change that, rerun this same query down here and hit enter. Now you can see that we do in fact get different titles down here. And these titles all correspond to the films that Kevin Bloom was in. Then down here a little bit more. So now we're going on to Rip Crawford, this actor, and you can see we have a different set of titles down here, and these titles do correspond to the films that Rip Crawford was in. I've stated out loud that these are the films that this leftmost column is the title of the film that these actors are in over here. A good, at this point, thing to do would be to sanity check your queries. Some of the queries that you're going to have to write on this pagila-hw3, my solutions end up being a little over 50 lines long on some of them. And so it makes sense to have little checkpoints that you're sanity checking that what you're getting is what you think you're getting. And so I have a hypothesis right now. I've proposed a hypothesis that like these leftmost films over here are the films that this actor is in, and we can verify that with another SQL query. So if I do something like select title, comma, actor, ID, comma, first name, comma, last name. So this is the query that I started with originally. From film, join film actor using film ID. Delete that typo, join actor using actor ID, and then add a where clause, in this case saying first name equals Rip. And I like to format it like this, and the last name equals Crawford. Then this query will give me all of the titles that Rip Crawford has been in. And so we should be able to use this query to just sanity check that these over here are in fact the titles that Rip Crawford is in. So I'm gonna just make a mental note, Alabama Devil, American Circus, those are the top two. Press Q to leave that environment, copy and paste this down here, and we'll see Alabama Devil and American Circus down here for Rip Crawford. So that does give me some good confidence that this query up here is going on the right track. Yes, Henry.
Are we able to use using clause for some of the joins and then the on clauses for other ones?
The question is, are you able to use using clauses on some of the joins? The answer is probably. So in this case, the actor table over here is not duplicated. So anytime you have an like the first name and last name, those are going to be unique to the actor table. But anytime you have any column name that is not unique to a particular table, you won't be able to use the using clause. And in this case, all of the things that we're joining on over here, they always involve at least one of these self-joined tables. And so in this particular case, there's no way to use the using clause, at least that I see, in order to do that join. In other cases, I can actually imagine in some of the later on homeworks, there would be situations where you could use the using clause for some things and the on clause for other things. In this case, I don't see a way to do that. Good question. Other questions? Yes.
Why would we do this instead of using like a where?
The question is that, so here I'm using a self-join here, and we could imagine other ways of solving this problem that do not involve self-joins, that involve using subqueries instead of self-joins. And the question is, why might we want to do it with a self-join instead of a subquery? The answer is that for the homework assignments, so maybe like we'll do a couple levels of answer here. Just from a strictly student speaking perspective, for the homework assignment, it doesn't matter at all. If you get the right queries, then you're good. So if the self joins don't make sense for you for whatever reason, then you're not required to use them, and so that's okay. As these self joins progress, they get to the point where the self join code is much simpler and smaller than the equivalent subquery code would be. And I think much easier to reason about. So I would encourage you to use the self-joins for that reason. That's one reason. Another reason why people would prefer just in general self-joins is that, again, these subqueries, strictly more powerful than self-joins. They can do things that self-joins cannot do. And in some ways that's a good thing, but in some ways it's a bad thing, because then if I see a subquery, my brain goes to like, okay, I need to panic. I need to like actually focus on what's going in here, make sure that it's not using that extra power. Once you're like more comfortable with joins, which is again, okay if you don't feel that way at this point, but once you get to the point where you're more comfortable with joins, you rely intuitively on the fact that joins can only do certain things that subqueries can't, and that makes the join code easier to understand. Also, when we get into the discussion about efficiency, we'll see that the queries might have different runtimes for subtle different reasons, that they're likely to be almost the same up to some very small edge cases, but those very small edge cases can cause the runtimes to explode in some situations. And the self joins here are, in general, going to be easier to get to run fast. But good question. Okay, the last thing here for us to discuss then is, let's put it all together and see if we're actually like solving the problem. That it seems like we are, we've written a SQL query that does this thing, but let's check the test cases to see what the output format should be. So colon tab E, I'll look at the expected, and we're looking at 05.SQL. Do I have a typo? Oh, it's not 05.SQL, it's 05.out, there it is. And so here we can see that the expected output should just have the titles and nothing else. It also looks like we can see that there are a bunch of duplicates in here that did not get removed. So maybe it's less than ideal that way. But everything was also ordered alphabetically, we can see. So let's make sure that let's make those changes. Come over here, get rid of everything that is not the title. I'll just comment that out so it's easy to add it back in for debugging later if I need to. And then down here, let's make our order by go on that f2.title. And again, down here, I still have to qualify which title I'm referring to because we could be ordering by title 1, conceivably. Copy and paste that down here. Let's just do a visual check to see if that output does in fact match. It looks to me like that's the same sort of output. Alabama, Alaska, Alien, American. First words of the first 4 lines. GG to the top. Alabama, Alaska, Alien, American. Down here, first 4 lines. That looks good. And so now I will check my results. Control D down here. And up arrow, change this from pSQL to the /run test.sh, and we'll see what happens. Uh-oh, I'm still getting a fail down here, so maybe we'll do a diff-u of our expected 05.SQL and my results /05.SQL like this. And they're not SQL, they're out. As an aside, sometimes I pronounce it SQL, sometimes I pronounce it SQL. I only pronounce it SQL. You may have noticed when I'm talking about file names where I'm actually talking about the letters themselves, and I pronounce it SQL whenever I'm talking about the actual language, like not talking about the letters inside that I'm typing at or looking at. So there we go, 05 out. And it looks like we have a bunch of rows here that have been added, all related to our Mr. Crawford over here, because I still have 2 select queries down here, and I still have this debugging one. If I comment that out, though, and save that, then down here, rerun my run tests, and now we get the pass, floating pass right there, 05, getting a pass there. Any questions from 5? Okay, so this is an example of a full credit answer. It is passing the test cases, but there is a better full credit answer, an easier one, and that is that we don't actually need this actor table anywhere. You'll notice that now that I've commented out this stuff up here, I'm never using this first name. I'm never using this last name over here. I'm only using the actor ID, and the actor ID is contained in the film actor and the film actor tables over here. So there's no actual need for me to join on the actor ever. And if I comment out that table, it's not going to work exactly as it is because I have this reference to the table up here, but I can change that YYP to Y for yank, YY to yank the current line that you're on. Anytime you double up a command in Vim, it applies to the entire line that you're currently on. DD, the most common of that, to delete an entire line, but YY to yank, which is Vim's terminology for copying. Yank the entire line, P to paste it. And now change this over here from actor ID to what my previous table was, film actor, FA1, FA1.actor ID. And this should be an equivalent query that doesn't use the actor ID anywhere. Save that. Let's just go ahead and run the test cases again. And it is still, in fact, passing, even though we've taken out that actor table. So very common in these, so self-joins again, summary self-joins, when you very commonly used on these tables that have two primary keys inside of them. These tables commonly have two primary keys when they're connecting two tables that are in a many-to-many relationship. One category can have many films inside of it. One film can have many categories. And similarly, one film can have many actors. One film can have many actors. One actor can have many films. And when you're doing those connections, you often are only referencing one of those tables, or you only need to reference one of those tables into this join table. You often don't need to go all the way to that second side over there. And again, for the homework assignment, anytime you're doing a self-join, it's always going to be between actor and film through the film actor table, or category and film through the film category table. Any questions about anything on problem 5 or the self-joins in general? Okay, that's a good spot for us to stop for today. So next class, we'll finish up with the counting up that row overhead. And tomorrow we will have a lab. So I'll see you all tomorrow. And that's it for today.